Okay. Next module is module number 4, groundwater exploration. Okay. Module 4, groundwater exploration. The name itself is suggesting groundwater exploration. What exactly groundwater exploration is? Simply investigation of the underground formations. Okay. Groundwater exploration, investigation. Okay. Investigation of underground formations. That's it, simple. Groundwater exploration, understanding, investigating, understanding about the below the ground surface. Okay. For what purpose? For what purpose? What is the purpose to understand the groundwater system or understand the groundwater formations? So these are all some purposes. To understand the hydrologic cycle, correct? After the precipitation, part of the precipitation flows as a runoff, part of the precipitation infiltrate deeper into the ground. Part of the precipitation infiltrate deeper into the ground, so that water reaches the aquifer. So we must understand, in order to understand the hydrologic cycle, okay, in order to understand the hydrologic cycle, the knowledge about groundwater system is must. Okay. Next purpose is to know the groundwater quality. Yes, of course. Before using for drinking purpose, we must check the water for quality for different kind of parameters. Okay. Next one is to identify the nature, number and type of aquifer. What is the nature of aquifer? Is it perched aquifer or unconfined aquifer, confined aquifer? We need to know this nature and how many numbers of formations are there, how many numbers of impervious stratas are there. Okay, nature, number and type of aquifers. So in order to understand these things, we must investigate the below. We must investigate underground formations. Okay, and next one is about methods. Basically, there are two types of methods: surface method, subsurface method. Again, the name itself is suggesting surface method, above the ground, investigations carried out from the ground, above the ground. Here, subsurface methods, subsurface, below the ground. Okay, these are the subsurface methods. Okay, surface methods, again we have 5 types of classifications: geologic methods, remote sensing method. I will tell you everything in the next few minutes. Surface geophysical method. Okay, in surface, this is important. Surface geophysical method, we have subclassification. We have 4 subclassification: electrical resistivity method, seismic refraction method, seismic reflection method and electromagnetic methods. Okay. In next one is magnetometer and gravimeter method under surface method, and next one is soil temperature details. These are classification under surface method. Now the classification under subsurface. So these are the classification. First one is the test drilling. The name is suggesting subsurface, below the ground. So this is test drilling and geophysical logging. Here we have 5 types: electrical logging, radioactive logging, induction logging, sonic logging and fluid logging. Okay. Now in next few minutes we will be discussing each one of these things one by one. Okay. Next topic is under surface method. Okay, we have 2 classification of groundwater exploration: surface method, subsurface method. Now let us discuss about surface method. Surface method, under surface method we have 4 types of classification. The first one is geologic method. The very first one is geologic method. The name suggesting this is all about geologic features, the data related to the geology. It may be map or it may be topo sheet, whatever. Okay. First one, this involves, the geologic method involves collection, analysis and hydrogeologic interpretation of existing geologic data. Just I said data or maps, okay? Existing geologic data, maps and topographic maps, aerial photographs and other pertinent records Using these kind of records, okay, we will going to analyze the system below ground, okay, using a map or data or aerial photograph or geographic maps, topo sheets, okay, topographic sheets, using these pertinent related records, okay, the records related to the geography of that area. Understanding a record, image, topo sheet, whatever, using these kind of record, we are going to analyze the below system, okay, underground system. Okay, this is about first point. Now second point, the type of rock formation. Okay, the type, there are n type of rock formation below the ground, system. So the type of rock formation will give us a magnitude of water yield to be expected. If there is a hard strata, if there is an impervious strata below the ground, then we cannot expect too much of water. We cannot expect high yield of water. Okay, in order to get the high yield, we should go very deeper into the ground. So the type of rock formation, we are going to obtain the information, we are going to obtain the knowledge about the rock formation. These rock formation gives us about the knowledge about magnitude of water yield to be expected, to what extent we can expect water. Okay. Next one is nature, thickness of overlying beds, and what kind of it is like that. Okay, nature and thickness of the overlying beds. Below the ground, again n number of different layers are there, sand or clay, or it may be an aquiclude, whatever. Nature and thickness of the overlying beds will enable us to estimate, and it means this gives an approximate estimate of drilling depth. This gives the thickness, the nature and thickness of the overlying bed. Nature and thickness of the overlying bed gives us an approximate estimate of drilling depth. At what depth we can expect water? At what depth we can expect high yield of water? So all this information we are going to obtain by studying the records, by studying the maps, by studying the topology sheets, etc. Okay. Next one is remote sensing method. Although, listen carefully, although remote sensing data do not directly help us, okay, do not directly detect the deeper subsurface resources. Okay, it is not helping us directly. Although remote sensing data do not directly detect the deeper subsurface resources, but it can be effectively used in groundwater exploration, as the remote sensing data helps in drawing the inference on groundwater potentiality of the region. This gives an inference. Okay, it is helpful to interpret the data. Okay, it is helpful to interpret the data, to write some inference, some note on the potentiality of the region. Can we expect water in this region or not? We are going to obtain the basic information. Okay. Next point is groundwater study of an area requires knowledge and nature of lithological units. Of course, in order to study the system below the ground, that is groundwater system, we must know about lithological units. Lithological units nothing but the study about rock, study about different kind of rocks. You already studied in engineering geology. Okay, there are n types of rocks, there are n types of minerals below the ground. So in order to understand the system, in order to understanding of the system, we must know, we must have knowledge and nature of lithological units, that is different kind of rocks. We must know basic information about lithological units in that area. In addition to the lithological units, and also we must know about disposition, structural disposition of the layers, structural disposition of the rocks, and surface water conditions, because surface water slowly recharges the groundwater. Over a period of time, surface water recharges the groundwater. So we must know about surface water bodies in order to understand the groundwater system, and also climatic factor of that area. Sure, definitely climatic factor affect the system. Okay, these can be, what are lithological units, climatic factors, structural disposition, surface water bodies. Okay, in addition to these, okay, these parameters, these points can be studied through satellite images and aerial photograph. Just by taking the images, we can study all these things. Remote sensing data are very accurate, correct? Compared to the conventional method, remote sensing data are very accurate, and the most important thing is very fast. We can obtain the data too fast compared to the conventional method, and also reliable, correct? As compared to the conventional methods, remote sensing data are very accurate, reliable, and too fast compared to the conventional methods. Next one, before geophysical investigation, before starting the investigation itself, the remote sensing data gives us the knowledge of the geography of that area, correct? Just by taking an image, satellite image, we can clearly distinguish what type of area is. Is it a forested area, or thickly forest area, or thinly forest area? Is it a hilly area, or urban area, whatever? We can easily classify, we can easily understand the geography of that area before investigation itself. So this will going to help a lot. Okay, yes. Next topic is about electrical resistivity method. This is one of the most important method of groundwater investigation. Okay, electrical resistivity method and seismic refraction method. Seismic refraction method will be explained in the next few minutes. First, the most important one to investigate the groundwater below the ground is electrical resistivity method. Carefully observe the diagram. There are two outer current electrodes. Okay, I mentioned here 2 outer current electrodes and 2 inner potential electrodes. Okay, here the basic principle is we are sending current through the outer electrodes, and the resistivity offered by the ground is measured using potentiometers. Okay, the ground level is there, 2 outer electrodes, and current is measured in ammeter, and resistivity offered by the ground is measured in potentiometers, 2 inner electrodes. Okay, and the basic principle here is each soil has different electrical resistivity. Of course, each soil, different kind of soil having different resistivity. Okay, each soil has different electrical resistivity depending upon the type of soil. If the type of soil varies, means of course electrical resistivity varies. So it depends on type of soil and also water content present in the aquifer or below the ground. If there is a water, then it is a good conductor, correct? Water is a good conductor of electricity. So now next one is compaction. How much extent the ground or the below ground surface compacted. Next one is composition of different minerals. Okay. Next, saturated soil has lower electrical resistivity. Saturated nothing but all the pores are filled with water. So having lower electrical resistivity. Correct? Resistivity is less, but conduction is more. Okay, as compared to the loose dry gravel soil. If there is a water, then current signals or current easily flows. Water is a good conductor. If there is no water, if there is no mineral, or if there is no any water content, it may be petrol, petroleum product or water. If there is no water or if there is no mineral, then resistivity is more, correct? Then resistivity is more. Distance between the electrodes, this one, D, distance between the electrodes. Distance between the electrodes is depending upon depth of exploration. It's left to us. If you want a more depth of investigation, then D varies, okay? Now first point, actually the basic principle is what just I said. We are sending current through the outer current electrodes and we are recording the resistivity through the by the potentiometer. So certain amount of current is passed between the outer two electrodes. This one current electrode and this is current electrode. Some amount of current is passed between the two outer electrodes and potential drop between the two inner electrode is measured by the potentiometer. Potential drop is measured by this potentiometer. And the mean resistance, we can calculate the mean resistance using this formula, rho is equals to 2 pi E by I, where E nothing but potential drop. 2 pi constant, E nothing but potential drop in volt, I mean current in ampere, and rho mean resistance in ohm meter. This is the formula to calculate the mean resistance. Okay. Now, average value of the resistivity of various type of soil can be established based on the experimental test by conducting experiment for different depth, okay, for different distance between the electrode, we can calculate the average value of the resistivity of the various type of soil. In general, we can establish. Now, a hard rock without pores or without fracture, consider there is a hard rock, okay, hard rock without pores or fracture, and dry sand without water. Consider a hard rock aquifer, there is no fracture, there is no pores in the hard rock, and dry sand without water. Then resistivity is more, correct? If there is a water or any mineral content, then it is a good conductor of electricity. If there is no water, in a dry sand, or there is no fracture or pores, that means there is no mineral content, there is no water, then resistivity is more, correct? Obviously, resistivity is more, very resistive. Resistivity is more. An impermeable clay layer, but having water. This is without water. This is impermeable clay layer having water. If there is a water, then it is a good conductor of electricity. So, good conductor of electricity, but resistance is less. Correct? It will not resist, correct? Now, mineral ore body. If there is a mineral ore bodies below the ground, if there is a mineral ore bodies like iron sulfates, etc., if there is a mineral, then it is a good conductor of electricity. Resistivity is less, then very low resistive. Resistivity is less due to their electronic conduction. Just I said, Because of the electronic conduction. It is a good conductor, na. It's a good conductor. Water is a good conductor. Mineral, if there is a mineral is a good conductor. It is a good conductor. Conductor means resistivity is less. Resistivity less because of the electronic conduction. Okay, by observing these points, okay, by analyzing these points, we can conclude that measuring the ground resistivity, we can say it is possible to identify the presence of water by measuring resistivity. Okay, if there is a water content or if there is a mineral content, it is a good conductor. Resistivity is less. If resistivity is less recorded by this potentiometer, if resistivity less means definitely there is a presence of minerals or presence of water body. If resistivity is more mean, if resistivity very resistivity more mean there is no water, there is no mineral. Without water, without pores in a hot. Very resistive. That mean what? There is no water bodies, there are no mineral content. Okay, this is all about electrical resistivity. Name itself is suggesting electrical resistivity method. Okay, just by measuring the ground resistivity, we will going to understand it is a possibility to identify the presence of water. Thank you.